Hello and welcome to another one of D's ADD videos. Today we're going to look at some basic examples of assigning oxidation numbers. If you remember when we went over the concept video, I gave you some rules to memorize, such as the oxidation number of a free element is 0 no matter how complex. The oxidation number of an ion is equal to the charge. The sum of the oxidation numbers must be equal to the overall charge of the molecule or ion. Molecules have 0 charge. There is a hierarchy again, remember, for assigning this. There's a reliability. Fluorine is the most reliable, is -1. Then the alkali metals, earth metals, hydrogen, then oxygen. So that means that anything towards the top of the list takes precedence over the bottom of the list. Alright? And I'll give you an example of that probably on the next intermediate video. But back to these basic examples, let's take a look at what we have going on here. Hydrochloric acid, HCl. If you remember on your list of priorities, hydrogen's here, but chlorine is not even on here, right? It's a halogen, group 7A. So what we do is we assign hydrogen a +1 charge and then try to make the overall compound neutral. I know hydrogen has a +1 charge. Well, what do I need to add to hydrogen to get a neutral charge? Well, that thing I need to add is a -1. So these now have their oxidation numbers. +1 for hydrogen, -1 for chlorine. Again, another scenario in which we don't have anything besides hydrogen and some other element. So when assigning, you would put a +1 here, but there are 3 hydrogens. So you do a 3 times a +1 to get us a +3 charge. Now what you do is you ask yourself, what must I add to a 3 to make it neutral? And the answer is a -3. So now you have the oxidation number for nitrogen is -3, and that for hydrogen is actually a +1. There were just 3 of them. Okay, be clear. So the oxidation number for the hydrogen was a +1. The reason that's a +3 because there were 3 hydrogens. The oxidation number for the nitrogen was a +3. -3. Alright, beryllium chloride. If you look on your periodic table, just in case you forgot, beryllium is the first element on the alkali earth metals, and that's going to have you an oxidation number of a +2. Chlorine is a halogen, not on the list of reliabilities. So if we come over here and we look at beryllium, we know beryllium is going to have a +2, and we want to know, what do I add when I multiply by 2 to get a 0? Well, the only thing I can make that a true statement is plugging in a -1. So then 2 minus 2 gives you a 0. So now the oxidation number for beryllium is going to be a +2. Then the oxidation number for chlorine is a -1. This one, because it's a free element, you automatically write 0, move on. This one, because it's an ion, you automatically write the charge of +1, and then you move on. Alright? So these are some pretty basic examples. They do get a lot more complex, so make sure you check out the example videos. Practice, practice, practice. Thank you and have a nice day. They do get a lot more complex, so make sure you check out the rest of the example videos, the intermediate and advanced examples. Practice, practice, practice so you can become proficient enough to handle the more complicated redox reactions without using the activity series involving these oxidation number changes. Thank you and have a nice day.